Okay, so in this video, this is just going to be a quick right triangle trig refresher. Okay, so this shouldn't take too long. I just want to go over the basics of right triangle trig so we're all on the same page moving forward. And to have some right triangle trig, I need a right triangle. So I'm going to go ahead and draw a right triangle. All right, it's not drawing the best, don't worry. It's a right triangle. And I'm going to be doing this all into relation to this angle down here, and I'll call it theta. Okay, and theta is just a variable for an angle that we use very frequently. Okay, I could have used this angle up here, but I'm going to go ahead and use this angle. Okay, and when we're doing right triangle trig, what we're basically just doing is the ratios of the legs or the hypotenuse in relationship to this angle. Okay, so remember these two sides here that are attached to the right angle are called the legs, and the opposite leg from the angle in question, theta, I'm going to call opposite. So this is the opposite leg to theta. All right, and the side next to theta, the leg next to theta, I'm going to call the adjacent. It's adjacent. It's right next to it. Okay, and then this side here, okay, the side opposite the right angle is actually that special side that we call the hypotenuse. Okay. Now, a lot of people remember their right triangle trig from SOH CAH TOA. Okay, a lot of people use this, and feel free to continue to use this. A lot of people remember based off of this alone. Okay, and this helps us break down our three basic trig functions. The first of which is sine. Now, the trig ratio for sine is opposite over hypotenuse. Okay, sine is opposite over hypotenuse, so you're going to generally see me and many other people shorthand this and say sine of theta is equal to opposite over hypotenuse. Okay, and our next part, CA, is cosine. Cosine is the adjacent leg over the hypotenuse. All right, and we shorthand this. The shorthand for cosine is a COS, so cosine of theta is adjacent over hypotenuse. Okay, and TOA stands for tangent. Tangent is opposite, the opposite leg over the adjacent leg. And the shorthand for tangent, is TAN. So tangent of theta is opposite over adjacent. All right, so let's go over just maybe two examples real quick. So let me go ahead and get us some new space. So I'm going to go ahead and draw a new right triangle. Okay, let's say this triangle here. Okay, ignore this part. All right, I'm actually going to use this angle up here. I'm going to call this theta now. Okay, I'm going to give us that this side here is 12 and that this side here is 13. Okay, now what we need to do first, if we want to go ahead and find our three trig ratios, sine, cosine, and tangent, I'm going to need all three sides. So I'm missing this leg right here. I'm missing the adjacent leg to theta. Okay, so I can find that very quickly by, remember, using the Pythagorean theorem. A squared plus b squared is equal to c squared, where a and b are the legs, c is the hypotenuse. Okay, and I know that one of the legs is 12. I don't know the other leg, and I know the hypotenuse is 13, so I can find this missing side by using the Pythagorean theorem. Okay, this is going to get me 144 plus b squared is equal to, that's 169. So I move the 144 over, subtract 144 from each side to get b squared is equal to 25, and I get b is plus or minus the square root of 25, but since we're dealing with sides here, a side cannot be negative, so I get that b is 5. So this side right here is 5. All right, and now what I can do is I can actually go ahead and find these three trig ratios. All right, so remember what right triangle trig remember what right triangle trig, let me go ahead and move this up. Remember that sine is opposite over hypotenuse. So what that means is, in this particular triangle, sine of theta is going to be equal to, now sine is the opposite leg, which is 12 in this particular case, over the hypotenuse, which is 13. So that would end up being sine. So sine, opposite leg over hypotenuse, okay? Now cosine is the adjacent leg over the hypotenuse. So the adjacent leg in this particular problem is 5. So right next to it, okay? So the adjacent leg is 5. The hypotenuse is still 13, all right? And then tangent is the opposite leg, which is 12, over the adjacent leg, which is 5. And that's all that this is, okay? It's simply just ratios, okay? It's just these ratios. So this would be sine, cosine, and tangent of this angle for this particular triangle, okay? Let's try one more. Let's do one more real quick. So let me get us some new space. All right. And I'm going to give us a triangle here. Let's go ahead. And that's our triangle. That's our triangle. Ignore this little part. I'm not that great at drawing. Okay. Actually, let me see if I can make that a little bit better. Yeah, better. All right, so this is our right triangle. Okay, I'm going to go ahead and use this angle down here. I'm going to call this theta. I'm going to go ahead and say that this side here is 7 and this side here is 24. All right, and what I want you guys to do, take a second and pause the video here. I want you to go ahead and tell me what sine, cosine, and tangent would be for this particular triangle. Go ahead and pause the video here and try it. All right, hopefully you tried that. I'm going to go ahead and find the missing side first. We first need to find the missing side, okay? And what we're missing in this particular triangle is actually the hypotenuse. So I know that 7 squared plus 24 squared is going to be equal to our hypotenuse squared. This would be 49 plus 576 is equal to c squared. This gets us 625. Is equal to c squared. So c is 25. Remember, we're only using the positive one, not negative 25. Remember, when you take the square root of each side, technically it's plus or minus, but since we can't have a negative side, we're taking the positive 25. Okay, so that means that in this particular problem, sine is the opposite leg, which is 24 in this problem, over the hypotenuse, which is 25. Cosine is the adjacent leg, which is 7, over the hypotenuse, which is 25. And tangent is the opposite leg, 24, over the adjacent leg, which is 7. Okay, so that is our basic right triangle trig. Make sure that you are very, very comfortable with our right triangle trig, because we're going to be basing pretty much the rest of this particular unit, which is graphing trig, the unit circle, identities, okay? Make sure we're very, very comfortable with this right triangle trig. Until the next video, bye.